All right. Let's suppose we have reference angles here. And let's take a look at reference angles here. Let's suppose I have the terminal side of an angle theta right there, okay? And let's consider that angle theta, and let's consider this one theta prime. All right, let's think about a point right here. This point P, we could call X comma Y. And we're going to call this distance right here R, this distance from this point to the origin. And let's make a perpendicular line right here, makes a right angle with the x-axis there. So what is going to be this length of my triangle? Be the same as that x coordinate there. And this length is going to be the same as the y coordinate there. Okay? Now let's look at find the cosine of theta and cosine of theta prime. Well, what's the cosine of theta equal to? We look at theta right here. What's the cosine of it? Cosine of theta is x over r, we said. Well, that's just simply what? Whatever x is over whatever r is. Not a big deal. Cosine of theta prime. Let's use the triangle here. Let's use this triangle that we drew right here. And let's find the cosine of theta prime. Cosine, if we have a triangle, is going to be, for this angle right here, is going to be adjacent over hypotenuse. So adjacent is x. Hypotenuse is r. So that's equal to x over r. Now, the only thing is, this one is going to be negative here, right? Because my x value over in quadrant number 2 is negative. So whenever we're looking at a triangle, we need to consider what the SIGN is of my trig function. What is a trig function in angle 2 for the cosine? It's going to be negative as well, right? So what we're getting at right here is if you use the reference angle, you will get the same thing as the cosine of that regular angle right there, and you'll get the same thing for all the other trig functions, the 5 other ones. You just have to be sure you adjust the SIGN if it's positive or negative. All right, so let's see. Use reference angles to evaluate. It's going to be our next example. Use reference angles. Use reference angles to evaluate. All right. And let's suppose for part A we have cosine of 3 pi over 4. Go ahead and draw a picture of this. 3/4 of a pi. Remember, this is pi over here. So 3/4 of a pi would be over in this quadrant, my terminal side of that angle. Theta is equal to 3 pi over 4. But it tells me to use a reference angle to evaluate this. So my reference angle is going to be right here. I can call that theta prime if I wanted to. And let's draw us a triangle. Let's drop a perpendicular line down this point. So this the x-axis makes a right angle. Okay. Now I could use that triangle and so forth and calculate values, but actually what I want to do this time is I want to go ahead and do this. I want to go ahead and say, okay, cosine of 3 pi over 4. Well, that's going to be equal to the cosine of my reference angle, theta prime, but is it going to be positive or negative of that? Think about where we're at here. the terminal side here is in quadrant number 2. So the cosine, if I think about my signs, all students take calculus, so the cosine in this quadrant is what? Negative. So the cosine of 3 pi over 4 is equal to negative cosine at theta prime. So that's negative cosine at, what is this theta prime? Let's try to do that in our head. What would that be? That would be pi, but then back off 3 pi over 4. What's pi minus 3 pi over 4? Pi over 4. Well, that's negative. What's the cosine of pi over 4? That's one of the ones we had to learn in a chart. Square root of 2 over 2. So cosine of 3 pi over 4 is negative square root of 2 over 2. Let's look at part B. Part B, we're going to have the same directions here for part B, but this time they're going to tell us, let me pull this up, they're going to say we want the cotangent, get my pen to right. Part B, we have the cotangent of negative 3 pi over 4, negative 3 pi over 4. All right, let's draw a picture of where this appears. Remember, if I have a negative angle, I'm going back this way, right? Remember, this is pi. This is normally pi over 2, right? But let's think about going backwards like this. Then that would put me at negative pi over 2 here. And if I go all the way here, that'll put me in negative pi. But I want to go negative 3/4 of the way. So I need to stop right there. And I'm going to say theta is equal to negative 3 pi over 4. Now let's find my reference angle right here. Theta prime. Let's do that in our head. Okay? Theta prime is going to be some positive angle right here, because we define it as a positive angle between the x-axis and the terminal side. Let's think about this for a second. How am I going to find that? If I were to go all the way around to here, that would be what? Negative pi. But I would need to take off this amount, right? So I'm going to say theta prime is pi, and then take off 3 pi over 4. That'll give me what? Pi over 4 again, right? It's got to be a positive. So what do they want? They want the cotangent of negative 3 pi over 4 is what they were asking me for, according to this. All right, so we're going to say that's the same thing as the cotangent of my reference angle, which is pi over 4. Now, if I'm in quadrant number 3 right here, what's going to be my sign of my cotangent? Remember, all students take calculus. Tangent is what here? Positive, so the cotangent is positive. What's the cotangent of pi over 4? Look at your chart. That'll be 1. Our next example. Going to say given cosine of theta is equal to negative 5/8, and cosecant of theta is greater than 0. Then it says find a sine of theta and tangent of theta. Find sine of theta and tangent of theta. Start out with this. Cosine of theta is equal to negative 5/8. But we also got to look at this, because this alone does not tell me which quadrant we're in. Remember, all students take calculus. So that means my cosine is positive here and here. So my cosine will be negative in this quadrant and this quadrant. But which one is it? Is it quadrant number 2 here or quadrant number 3? Well, this is going to tell us that cosecant of theta is greater than 0. Where is the cosecant positive out of these two quadrants right here? It's going to be positive in quadrant number 2. So I'm going to draw me an angle with a terminal side in quadrant number 2. Don't care about drawing the scale. Just want to draw it in quadrant 2. Okay. Now here's my angle theta right here. Go up a little farther. Let's use a reference angle this time with the triangle. So let's go ahead and say, okay, here's theta prime. And we're going to drop down a perpendicular line and makes a 90-degree angle here. And we're going to look at the cosecant of theta is -5/8, which should be the same thing as the cosine of theta prime is equal to -5/8. So if we look at theta prime right here, the cosine of it's -5/8. What is a cosine in a right angle defined as? Adjacent, right here, over hypotenuse. Well, this will be -5, and that'll be 8, right? Now notice how this one is -5. Why? Because this value of 8 is that distance right here. Remember we talked about distance has to be positive or 0. It can't be negative. So let me see. If I want to go and find the sine of theta over here, sine of theta, if I'm going to use that triangle, I might want to know what this side right here is. How can I find that side? You guessed it, use the Pythagorean theorem, right? But what is C? C has to be that 8 right there, 8 squared. A and B, it doesn't really matter if you mix them up. I'll call A the -5, and then B will be my unknown side. So that's 25 plus B squared is equal to 64, right? So what do I get whenever I subtract 25 from both sides of this thing? I'll get B squared is equal to 39. And if I take the square root of both sides, square root of B squared is equal to plus or minus the square root of 39. Or that gives me B is equal to, now B is this length right here. Is that going to be positive or negative there? It's going to be positive. So I'm going to use square root of 39. So we're at the square root of 39. Now what is my sine of theta? If I look at theta prime right here, my sine's going to be what? This side over hypotenuse, or the square root of 39 over 8. Now let's make sure I got the right SIGN on this. In quadrant number 2, what is my sine function? It's positive. That has the right positive or negative on it. What else do I need to find? The tangent of theta? Tangent of theta will be the same as the tangent of theta prime, but maybe you have to adjust the sign. Let's see. What's the tangent of theta? Square root of 39 over what? -5? Or I could say negative square root of 39 over 5. And what should the tangent be in this quadrant? Tangent should be negative. So that works. All right, and one more example. We're going to have find the value. Find the value. And suppose we have the sine of 11 pi over 6 squared plus the cosine of 4 pi over 3 squared. Remember, that's the same thing as writing a sine of 11 pi over 6 like this, quantity squared. And the cosine, I could say that's the cosine of 4 pi over 3 like this, but all quantity squared is what that means. Let's look at this sine of 11 pi over 6. Off to the side, get some scratch work. 11 pi over 6. I don't know where that belongs. So I could convert that to a mixed number. What is that? 1 and 5, 6 of a pi? Think about where I'm at now. Here's pi. Here's 2 pi. Here's 3 pi over 2. If I go 1 pi, I'll be right there. And then 5/6 of another pi puts me right here. It's 1 and 5/6 of a pi. So what does that mean my reference angle right here is? How much more do I need from 1 and 5/6 here to get to 2? I need 1/6 of a pi, or I can say pi over 6. So what I'm going to do right here is I'm going to say this is the same thing as a sine of pi over 6 squared, but pi over 6 is really in the first quadrant. What is my sign in this quadrant, positive or negative? So you all students take calculus, sign is negative. So I'm going to need a negative here. So in other words, the sine of 11 pi over 6 is the same thing as the negative sine of pi over 6. Plus, how about the cosine of 4 pi over 3? Let's replace that with a reference angle that we know the value of. All right, here's pi. Here's 3 pi over 2. Here's 2 pi. 4 pi over 3. Is that the same as 1 and 1/3 of a pi? As much as 1 pi. 1/3 more of a pi puts me there. So what is going to be my reference angle right here? It's going to be what? It's going to be 1 and 1/3 pi minus pi. Just be 1/3 of a pi left, or pi over 3. My reference angle here is going to be pi over 3. So we could say that the cosine of 4 pi over 3 is going to be the same thing as the cosine of pi over 3, and make an adjustment here. Does it need to be positive or negative right here? Well, let's see. Tangent's the only thing positive in this quadrant right here, right? So it's going to have to be that negative that we have. All right, so this is negative. What's the sine of pi over 6 according to our chart? 1/2, but we still have to square it. Plus, negative. What's the cosine of pi over 3 according to our chart? Well, think about that for a second. That's going to be what? 1/2 as well. And I still have to do what? Square it. So let's see. What's negative 1/2 squared? 1/4 plus negative 1/2 squared is 1/4. 1/4 plus 1/4 is 2/4, or what? 1/2. Voila, there we go.